Next up, we have Maher Lahmar, Head of Data Science at Google, who will take the stage to share his perspectives on building AI products, building causal AI products for effective decision-making.
Thank you. Thank you. Thank you. Well, I'm glad to be here. So I will start first with this. It is statistics. So obviously, it's kind of not the best word to say here in an AI conference. But I want to tell you a little bit. 2 years ago, just like I was preparing for holidays with my family, I got the news, and it was not a good news. That basically took me through a marathon of tests and scans and stuff like that. Luckily, I'm doing well. But at that journey, I got exposed to a lot of interesting things. And being a data scientist, just the perspective I've seen was very, very different. At least when I talked to the doctor, kind of, okay, after all this, she said, okay, you will do this, you will do that, you will do this, and you will do that, and then it's after this, you will do that, right? It's like, okay, hold on. How did you figure out all this? How do you know that this is the right thing to do? And the answer was actually, it is statistics. That's what she told me, literally. Now, well, obviously, if you tell me that, it's kind of I have to know what statistics we're talking about. And this kind of took me to a journey of basically trying to understand what is the scientific literature behind all this. And that was really an insightful experience, as well as kind of probably productive, and as I will talk about it later on. Who I am, I'm Maher Lahmar, and I'm heading data science team at Google. For the last 10 plus years, actually, experimentation has evolved in a significant way. So I see some people here from Target, was Cartwheel when it was launched. We were kind of trying, this kind of the, I think Red Circle or something like that this time, but we were kind of experimenting, trying to understand what's the incrementality of having that app. Same thing at Walmart. I was there kind of leading the Sam's Club as well as the Walmart US. And there was a lot of experimentation happening at the stores, 4,000 plus stores, at least Walmart US alone at that time. And there was a lot of experimentation on the merchandising, on the pricing. Same thing at IBM. When you have a product, a lot of feature product analytics on top of that to understand the customer engagement. And now at Google. That's a journey, and it only got better. It just like there are a lot of cycles of boom and bust, right? And we're living through probably one of them. But the reality is that the use of data, the use of science kept always going forward. What I want to say here is that there is there's a unique opportunity before us. It's just the excitement around science right now is to the roof, and that has not been the case before, right? So we're really glad to be in this era as scientists, but also the causal inference in AI can enable effective decision making if done right, and if there is basically I don't have to kind of probably. Convince you here in this room that causal inference or causal AI is actually the way to go. I think everybody's convinced, and here you're kind of trying to learn from each other. But the idea is that cross-pollination is important. I go to conferences. Most of the conferences will be focusing on pretty much an industry or a specific thing. But the reality is that there's a lot going on across the industries, across different applications, and there's a lot to learn from each other. And if I manage to get that message across, it will be a good presentation, at least for me personally. Google is a big place, obviously. It's a big business. But where do I sit at Google and what I do? So this is about Google Ads business organization. So it's kind of the engine of growth. It's kind of the SMBs for Google Ads. And the organization ensures that the strategy, the operations, and the products are actually done right so that we are having an effective interactions with our customers. We provide a good customer experience as well as we operate at scale. So these are all things important for us. And within that, we have a lot of, I will be walking through some of the things that we do classically, but then I will take you through a journey of where we are trying to change the dynamics here of what we do. So this is roughly what some of the use cases we have. One of them is about strategy. So strategy is about resource allocation. So understanding you have large organizations of people who are working with customers. Obviously, they are not kind of one bulk, one group, but they are kind of segmented based on customers, based on regions. And the question is that where do you want to invest your resources? They are still limited, and you would like to make sure that they are positioned in a place that they will help our customers best. Same thing, it's the operation side and the program design side. So programs is basically a cohesive set of rules and policies that are used for a certain customer segment. And coming up to the program design, this is basically what decides how we will be selling or how we will be interacting with our customers. And finally, the product, and which probably most of you are familiar with, is kind of activation of the product, how the product is being adopted by our customers. Well, these are some cases I will be kind of probably glimpsing through them. You probably have seen them before. This is an example of where we have a specialist program. So these are kind of specialists, they're kind of sellers, but they are special sellers. So they have very specific expertise and they join specific calls to add value. The question is that what is the added value that they have? And because that's important for us. So we do a lot of experimentation on that. The question here is that should we increase the size or should we not? Right? And this is pretty much something that we do where we work on the boundaries. So we don't have to basically do the test experimentation basically on the entire group, but rather we have to focus on the boundaries, kind of randomize on the boundaries, and that's what will get us whether we have actually a statistically significant effect there or not. And if we don't have one, the question becomes is that what to do about it, right? What to do is basically should we make the program smaller? Should we change the incentives? Or should we think differently about the whole thing? So these are some of the things that we should think about. So eventually translates into some decision of some sort. These are other things. So this is also kind of the program sizing. So we would like to know, okay, should we, where the program, so this kind of cohesive policies, what's the right group to do, right? And then you can think about it. So you have, this is more of an observational study here, but it's also to minimize the bias, we have to work on different techniques. And eventually we do simulations to identify opportunities to increase that kind of threshold. Should we move it up or should we move it down? Because that has implications. I mean, do you want to overserve or do you want to underserve? Both are not good for anyone, right? Now, another example is product adoption. So there are different ad products that are being updated and eventually kind of pitched to the customers. And the question is that, are they really adding the value compared to what we have before? And that's kind of where we do some random, basically RCTs kind of examples. It can be simple, but it depends on the case. Sometimes it gets really tricky as well, kind of complicated. Now, well, this is, obviously there are a lot of experimentation to be done. And within our organization, we have a good relationship with our stakeholders to understand which ones should go and which ones probably we should not. And I think everyone have in one way, shape or form, a way to prioritize what to experiment and what not. So in this case, for instance, we want to think about it as experimentation happens when you have high uncertainty and high impact. If you are really on the lower corner where you have really low impact, probably should not care. If you have low uncertainty, you probably know what is happening and you're not really, there's not much risk. So the idea is, okay, how can you identify those experiments or those hypotheses or whatever the kind of the business decision to be made that is on that top right corner. Not only that, but also we do have a system that is, this one is probably Google-wide system. Probably Chang can speak better about it later in his panel, where we have a tier system. So experimentation is fine, but not all the experimentations are born equal. There are tiers. They're the ones that are pretty much well done experiments, where you have a well-randomized groups, you have really, you're monitoring the integrity of these groups, and you're really doing it right. And there's another case where you cannot experiment and you have to do an observational study. And observational studies can be done right, just like it just can be correlational. And that will make it tier 1, tier 2, and tier 3, and that matters for the business because they would like to probably get into your tier 1 because that guarantees that they will have probably more support for their projects or initiatives. Now, you can see that we're trying hard to make this experimentation successful. But there are challenges, just like any other place, and these are some of the challenges we face. So if we think about experiments, they may not support the business partners fully, right? So in that sense, so there is always a cost to experimentation. There is always some effort put there, and sometimes it's almost impossible to do it. The operational complexity also is there. Remember, we're not putting like a button here, right? We're not having a red button and a blue button and kind of let's see which one is better. We're talking about really big initiatives that is disruptive to sales, it's disruptive to our customers, so we want to be very careful about that. And the business objectives, again, it's just like we heard it before. I think the business question is not, can you experiment for me? They want to make decisions. When you tell them that this is up or this is down, great. And the question is that, why? And then what should I do about it? So you're not really covering the entire ground here. You're not answering the question. You're just probably covering only a piece of it, right? And that means that we have to really think bigger and bigger all the time. We can do the manual processes as we were talking, but really we have to make it automated. We have to bring our people to kind of have pipelines, data, engineers, and eventually make platforms and things that work at scale. But also the business would like even to let me do it by myself, self-service. Well, we sometimes kind of, we think maybe it's not the right thing to do. But let's go back to our model that we have been talking about. So typically what we're thinking about is relatively robust, but also, it's relatively simplistic. So the way we think about it is that, okay, you have an account, it's assigned to the program, then you have a treatment. The treatment is influenced by some confounding variables, and also that will impact the effect or the impact, the incremental revenue or incremental metric that we are looking at, and that's kind of what it is. So this is kind of a simplistic view of the world that we live in. The reality is a little bit different. So back to the challenges we have is that actually we do have time dependencies. Things when you have a treatment, there will be another treatment, and there will be another treatment, and they are not completely independent. And you have also outcomes as you go, and you are observing a certain variables change as you go as well. The other thing is that treatment is not one. There are a lot of heterogeneity there. So treatment as, okay, you may be pitching, you may be educating, you may be trying to help. So it can be anything. And also the interference. You probably heard the Uber kind of examples, Airbnb examples, stuff like that. The interference is a big deal, and we want to make sure that we also don't get caught into that trap. So the way, for instance, how we decide about the unit of measurement is important because once you have any kind of constraint or certain, I'd say, a limitation, you may end up having interference. So if you have, for instance, you're assigning accounts for, let's say, reps to work on them, and then you make an incentive for one, not the others, you may see something shifting, right? So that does not really work well. So you have to think about what's your unit of measurement to reduce your interference. Now, I started basically with my joke, which was not very funny, but that was really important for me in the sense that when I started looking at the epidemiology research, it was really fascinating because I would say they don't have room for error, okay? So they're not marketers. They're not, I don't know, you can go right and left. This is kind of human life, and I think it's important to understand why and understand how we get there. The disease treatment planning in particular was fascinating. So understanding that and seeing how thinking about patients and how the effective treatments are done. So think about it. This is actually the real world example. This is what happens. It's not just 2 boxes or 3 boxes, and this is how the treatment and the outcome happens. Actually, you start with a treatment regimen defined. So this happens at the beginning of the treatment. Then you go, you have a treatment of some sort. Then you have tests and scans, understand things. Then you probably see the tumor size here. And then maybe another treatment now, right? And then you have another test. And all this keeps going on, right? And you keep looking at the tumor size. And probably I'm exaggerating a bit here because we don't have so many points, but the reality is that the models are the same. It's time dependent. The treatment that you have here depends on the treatment, depends on the tumor size, depends on the test results. It's not just in vacuum. If you make only one decision about one treatment and you think that you got it, you did not. Same thing for us, by the way. If we think that we put our emphasis on having a treatment, that means interacting with the customers and try to basically increase revenue in one shot, you may be able to get it once, but you will lose your customer because you're just optimized for one treatment. So now think about it. I just changed a few words here. I changed the regimen by an assignment, a treatment by an adoption, test results by other metrics, the tumor size by revenue, the doctors by sellers, and the drugs by offerings. And I get the same picture. The same picture says is basically you assign our customers to a central program, then there will be an adoption of the offerings, we will have some variables here, co-funding variables of some sort. We will watch how revenue goes, and then there will be another adoption, and things keep going, and you will see how complicated those influence arrows are. Well, and eventually, if you want to change the regimen, this is the equivalent of changing the assignment to the program. Now, things are also not as simple. If you recall, I probably did not cover that one, you see that when we talk about treatment, it's not one thing. It's not a 1 or a 0. The treatment is multiple doctors recommending different treatments of different dosages. It's complicated. But it's also complicated in our world because when you have an interaction with your customers, you're not seeing it as a 1 or a 0. It's actually also, there are different sellers. Sometimes they show up, or reps, they talk to clients together, right? Remember I told you there's a specialist there? Also, they have different offerings that they are talking about, as well as sometimes these reps, they may follow best practices just like they may not. Think about the dosages kind of idea, right? They may not do the right thing. So, what I want to say here is that there are emerging research opportunities in combining traditional causal inference techniques with AI models. There's a huge thing here. Big opportunity. We do feature balancing, structural linear equations, propensity matching, Bayesian models. We have been doing something of the sort. But then there is also machine learning, deep learning, encoder, decoders, transformers. All these are actually coming out, and I'm seeing research actually using the latest and greatest and trying to solve bigger problems at scale. Now, so what do we do about it? So I'm going a little bit into the mechanics of what we do. That means how we are building a product that measures the impact or the incremental metric that we're talking about here. And that's very different than having one, basically an ad hoc kind of analysis, right? It's not experimentation. So it's kind of, you have to go through the diagnostic, identification, modeling estimation, validation or refutement, and refinement. Now, let's talk about the first one. And some of the speakers before me have spoken about this. How to basically do the discovery. Diagnostic, you call it anything here. I think what's important is that there are different ways to do it. You can do it simply by expert opinion. You can do it by causal structure learning. And you can do it by LLM-based discovery too. Or you can do all these. Now, you can start easily. I don't think LLM is working for us because it's kind of a very specific case. At least it's very narrow. But there is room for using the causal structure learning as well. And using graph databases there. Now, the modeling is using the DAG, the direct acyclic graphs, to understand exactly what are the relationships and trying to look kind of link all these together. The pitches, the actions, the variables, the outcomes, and eventually how all this influence each other. And then comes the model. What model you'll be using? Because it's causal, we have to always think about the propensity network. So with the propensity network, it's important to think about the inverse probability of treatment, as well as the prediction network. And you probably have seen it in different places, but we can take it to a whole different level. Now, this is a question that I heard many folks asking the same question, which is, how do you validate your counterfactuals? And there are many techniques of refutation that are used. It's kind of common literature, nothing really secret here. It's actually looking at different tests. From sufficiency test, SOTFA test, placebo, dummy, variable. So basically, it's a sensitivity analysis to make sure that when we play with these things, we get the outcome that we expect. And that's one way to actually do the validation of counterfactuals. Now, easily said than done, because it's a whole simulation that has to be done whenever the system is very complex. Now, I'm getting into the last slides here. This wouldn't happen also within a data science team. We still need support. We still need adoption. So it's important to have support from the business so that you get at least the guidance of what the problem is and what the assumptions are, but also get in a science advisory board. Basically, the greatest folks who are around who can understand causal inference and kind of show you your blind spots. Finally, the journey continues. There are a lot of challenges. I wouldn't say it's kind of done. Nobody have figured it out yet. It's kind of research. The time variant treatments is probably question mark. Heterogeneity of treatments. Explainability is a big thing. As I mentioned, my business partners are always looking for why and how can I make it better. We talk about hybrid approaches. We always talked about experimentation aside and the counterfactuals aside. What about if we have both? Some programs will have basically holdouts and others they don't. And finally, we did not talk about quality of data here, right? Data is super important. To get it right, you have to have the right data, you have to have fresh data, good coverage, and that's necessary for your success. And to basically kind of wrap up my talk here, if there is anything I would like you to take away is that we really, there's a lot of excitement around science. At least on my side, I'm kind of being pushed to do even more and more for my business partners, which is a great thing to have. But also, there's a huge potential to make effective decisions at scale. And just don't forget that cross-pollination, cross-disciplines is critical to actually advance the field. So with that, I will end my talk, and thank you.
Thank you. We're going to squeeze one question, if that's okay. It's a big question, though, but I'd ask, yeah, can you do it in 30 seconds, right? How do you avoid local optima with many, many A/B tests that have small effects and are adopted incrementally, leading to bad global outcomes? So it's that.
That's a loaded one. So we don't have a. So I don't think I talked about this problem of having many, many, many A/B tests. So I think we try to make sure that the A/B tests are not corrupted by other A/B tests. We want to make sure that there is the integrity of the holdouts. We want to make sure that we kind of have some hierarchy in how we are deciding about the different tests. But that's at least to answer the question of having many A/B tests at the same time. The rest of what I was talking about is much more on the counterfactual side. So these different refutation tests are actually much more about counterfactual because we don't have basically a truth. We don't have any kind of holdouts that actually anchors us. So that would be the answer.
Perfect. Thank you.